We were doing capacitor, and did you do some homework?
जी सर मैं आपको आज शाम तक भेज दूंगी ग्रेविटेशन का
Good. And we were doing capacitor, and in capacitor we were doing series and parallel, but you have to check that what we were doing in our last class.
We did the derivation for Kirchhoff's first law.
Capacitors, eh?
We did the derivation for Kirchhoff's first law.
But that was using Kirchhoff's first law, but actually it's a derivation for capacitors in parallel. We made this formula, right? So now we summarize. We are doing our chapter is capacitor. Capacitor is a chapter which does not come every year. It is relatively a small chapter. Now let's have a summary. In series, capacitance decreases. In parallel, capacitance increases. This is something which is opposite when it occurs to resistors in series and parallel. So you have to now copy this screen.
Done.
So this is our concept of capacitor. So when capacitors are connected in series, capacitance decreases. So if you want to decrease the capacitance, you have to go in series. And if you want to increase the capacitance, you have to go in parallel. Now, safe working voltage. This is something which is very common now. Everyone knows that every device has a threshold voltage. When you buy a mobile phone, you buy a corresponding complementary, maybe complementary present, or you buy a corresponding mobile charger. It is called a concept of safe working voltage, because if you connect it randomly in the system can blow it out. So every capacitor has a safe working voltage. If the voltage is too high, the insulation between the capacitor plates may break and the capacitor can be permanently damaged. So give a side heading, safe working voltage.
Done.
Now you have to copy this concept. This would be our first concept technically for today.
Done.
Now, for example, this is a capacitor and it is connected in 10 volt, but the capacitor has a safe working voltage of 5 volt. So it is not safe to connect it. So it is not safe to connect. It is not safe to connect this capacitor because it will blow it out. until you put a load resistor. This is something I discussed in my last class. Until there is a load resistor in series. Now, the concept is there that series combination is capable of controlling the voltage. So if you connect this capacitor, it will surely blow and the capacitor will be permanently damaged. Capacitor is a sealed component. So once it is damaged, it can't be repaired. It is just like an IC. So now what is the solution? So if this is the capacitor, you have to connect a load resistor with the capacitor, and then you can connect it with the same supply. So if this is 10 volt and the capacitor is happy at 5 volt, then the load resistor must be able to share 5 volt. This is the concept of using a load resistor. Otherwise, capacitor would be damaged. This was our first concept for today. Now we move to our next title, combined circuits. Actually, we were doing capacitors in series, capacitors in parallel, and now we are putting the third number. I think we made a list. If you can check for me, I think we made
this was the third one on the list.
Right. So this is combined circuit number 3. Combined means series and parallel both. So when you want to make a combined circuit, you can see this is a circuit in which there are 2 capacitors in parallel and 1 capacitor in series. This is called a combined circuit. So give a heading and write under it series and parallel both. Series and parallel both. Again, this is a very technical concept to understand. Majority people do not understand that why we are going for this all headache, that we are connecting resistors, capacitors, power sources in series and parallel. Actually, power sources, resistors, capacitors are available in one single fixed value range. Normally, cells are available in 1.5 volt. So when you buy some cells for a remote control, you know that one cell cannot drive the remote, so you buy 2 cells. Similarly, you connect resistors, capacitors in series, parallel, etc., because they are available in some fixed numbers. This is actually a concept of aggregation. It is just like the concept that when you make a wall, you combine bricks, because you know one brick is available in a particular size. You can't buy a whole big brick to make the wall. So it is like the brick combination. So this is called the combination of capacitors, resistors, and power sources. Now you have to write under it that capacitors, resistors, and power sources. Capacitors, resistors, and power sources are combined. Capacitors, resistors, and power sources are combined to get the target value to get the combined value now. You have to copy the example number 1.
Done.
Now, remember, in capacitors, parallel works like resistor in series. And in capacitors, series works like parallel in resistors. उल्टा होता है. Series resistors का series capacitor का parallel है. और resistors का parallel capacitor का series है. तो अब आपने इसको रीड कर लिया. अब देखो इसकी वर्किंग चेक करो. These two capacitors, I'm joining them directly. 20 plus 20, 40 ohm. और वो जो आगे वाला, देखो ये वाला जो दिस कैपेसिटर, ये वाला, ये सीरीज में. सो आई हैव कंबाइंड इट बाय अ सिंपल कैलकुलेशन. सो पैरेलल एंड सीरीज. सी पैरेलल में यू डायरेक्टली ऐड एंड सीरीज में you go for the fraction formula. This is opposite to what we used to do in resistor. ये मैं बार बार क्यों highlight कर रहा हूँ? Because after doing the chapter of capacitor, there is a confusion always that what to do in series and what to do in parallel. Okay, in capacitor, parallel में you directly add. In series, you add in fraction, in C1, C2 upon C1 plus C2, product upon sum. Okay, now you have to copy the working.
Done.
Now, you have to copy example number 2.
Done.
Now, you can try it yourself, and the above two, these two are in series, and this one is in parallel.
Is it 17.5? 17.5.
17.5 is the final answer. Good. Now see example number 3.
Will it be 25?
The answer is 25. Good. The final answer is 25. Now, a very interesting question can be thought here, that when every capacitor is 25, then what is the benefit of connecting them in parallel and getting the same 25? I mean that if 25 was the target, then why don't we use one capacitor? The answer is again the same concept कि आजकल हम सर्किट्स में सिंगल डिवाइस कंपोनेंट नहीं लगाते बिकॉज सारा लोड उन्हीं पर आ जाता है. दिस इज अ कॉन्सेप्ट ऑफ सेफ्टी, सेफ वर्किंग वोल्टेज. अगर हम इस तरह कैपेसिटर लगाएंगे तो जो भी वोल्टेज अंदर आएगा वो डिवाइड होगा एंड इट विल बी सेफ. Now we are moving towards our next title, energy stored in a capacitor, and now we are going for the formula. This is a concept which is one of the most important concept of this chapter. In every A2 chapter, this is where A2 is very nice because A2 has a limited number of concepts and every concept unfolds and its concepts go in detail. So unlike AS where the concepts are so many, आप count करते जाओ खत्म ही नहीं होते AS में. A2 is a memory base. So अब देखो, this concept was discussed before that why capacitor or how capacitors are able to store energy. When a capacitor is charging, some work has to be done by the battery to give electrons. This work done becomes energy storage. It is just like you press a spring, so you have to do some work. This work done becomes the elastic potential energy. Similarly, when you charge a capacitor, you do some work. This work done converts into electrical potential energy. So this is our next heading, energy stored in a capacitor formula. Now remember this concept that this is a capacitor and we are doing some work to store energy in the capacitor plates. Now charge is directly proportional to voltage. The sketch is a straight line passing through the origin. And if you draw this sketch again, you will find that the area is equal to half QV. Half is there because of the triangle. So area will be representing energy. Now, after giving the heading, you have to write under it. After giving the heading, write under it that when a capacitor is charging, some work has to be done by the battery This is stored as electric potential energy. This is stored as electric potential energy. Now you have to copy this screen.
Done.
Now see this one, this is a sketch and area is half QV. Now you have to copy this.
Done.
Now, remember this Q into V. ये formula जो है, this is a very important formula, but somehow it's very unknown for many people. Charge into voltage. When you translate it into in terms of unit, joule per coulomb into coulomb, it becomes joule. So it means area under the sketch of charge against voltage is the energy stored in the capacitor. This is our AS style. कि हम AS में करते थे कि आप यूनिट की लैंग्वेज में आ जाएं. If you can come into the language of unit, so you can find out कि ये कौन सी quantity है. So this derivation shows that it is actually, the unit is actually energy. You have to copy this now.
Done.
Now, look at the formula half QV. If I use the formula Q is equal to CV, then it becomes half CV square. If I put V is equal to Q upon C in this yahan par. So if I put it here, so I will get half Q square upon C. This Q is also replaced here. So the main formula is half QV and the other two formulas are of the extension. You have to copy these formulas.
Done.
Now, energy change when you are using a capacitor. Suppose a capacitor is discharging, so it will be losing its energy. Capacitor is discharging just like a balloon is losing air. So when a capacitor is discharging, its energy amount is changing. In that case, the capacitor voltage also changes. This formula is used to determine the change in energy, half C V2 square minus V1 square. You have to copy this formula.
Done.
Now, the total energy supplied by the capacitor, total energy supplied by the source is QV. And the formula says that total energy stored by a capacitor is half QV. This means that every capacitor is actually not very efficient. Only half of the energy is stored. Relation between electric field and capacitance.
Done.
Relation between electric field and capacitance. This is our next title. Now, this is a concept. Now, look, when you make a capacitor and when you charge a capacitor, you will notice the formation of an electric field. When you charge a capacitor, you will find there is an electric field between the plates. On the reference previous chapter, when you charge a sphere, it is when you charge a sphere, it produces an electric field, but it also stores an electrical charge. So this was a concept which later developed that when you make a capacitor, it acquires an electric field, and when you make an electric field, it acquires capacitance. So this is a very interesting concept, that electric field generates capacitance and capacitance generates electric field. Okay, so after giving the heading, write under it that when a capacitor is charged, an electric field is produced between the plates. An electric field is produced between the plates. Now you have to copy this screen.
Done.
We have produced an electric field. Now, this is a sphere and we have placed it on an insulated stand. We are charging insulated stand. Now, you can see here that the sphere is charged. It's a charged sphere. Now, when you charge the sphere, what will happen? It will produce an electric field, but you can see it is holding the charge also. Now, what is the concept? Concept क्या है? अगर आप किसी चीज को चार्ज करें तो वो कैपेसिटर बन जाएगा, और अगर आप किसी चीज को कैपेसिटर बनाएं तो वो इलेक्ट्रिक फील्ड ले लेगा. Capacitance produces electric field and electric field produces capacitance. Now you have to write under it, when a metal sphere is charged, it acquires capacitance. When a metal sphere is charged, when a capacitor is charged, it acquires, when metal sphere is charged, it acquires capacitance. Now you have to copy this screen.
Done.
Now you have to copy this concept.
Done.
Now give a side heading, derivation, something which is speciality of A2 level. Derivation. And copy the first step. This is coming from our previous chapter. V is equal to Q upon 4 pi epsilon naught into R. When in this chapter says V is equal to Q upon C, and we are going to compare the two equations. We have to copy this.
Done.
So when I compare them, I can cancel out Q, and I will be left with a new formula of capacitance.
Done.
Now, this is the idea coming here. A charged sphere is behaving like a capacitor, and a capacitor is behaving like a charged. A capacitor is behaving like a charged object. Now, right under it, this formula shows that when a capacitor is fully charged, it possesses an electric field Okay, now you have to give a new heading, the time constant. This topic was added in our course in 2022. It means it's a brand new topic. It is actually related with discharging of a capacitor, but it's a new topic, so we are doing it separately with the marking as our rule, tagging. So you have to give this new heading. And this is going to be the last topic of this chapter.
Done.
Now, this is a concept coming from the idea that when a capacitor is discharging through a resistor, it is taking some time. So what we are now discussing, that how long it will take for a capacitor to discharge. In simple terms, you can understand it by an example, that for example, you charge your mobile fully, okay? Then you start using it. It will take some time for the battery to discharge fully, maybe 1 day, maybe 2 days. This is called time constant value. For a capacitor, you can't go for a day. It doesn't take that much long. Capacitors are generally in a hurry to discharge, but this is a concept coming here. The time constant of a capacitor is meaning the idea of discharging time, in which it completely discharges. So you have to copy the first concept.
Done.
Now, see that point, the time taken for the charge of a capacitor to decrease to 0.37 of its original value, ये बिल्कुल एक फ्रैक्शन टर्म में है ना, जैसे हम कहते हैं आधा हो जाए, हाफ लाइफ में बोलते थे ओ लेवल में, या हम कहते हैं 1/3 हो जाए, इस तरह 0.37 एक रेशो है। अगर कोई चीज पूरा 1 है तो अपने 0.37 तक रह जाए। एक्चुअली जब आप डिस्चार्ज करते हैं किसी चीज को तो वो अक्सर 0 तक नहीं पहुंचता। 0 पर वो पहुंचने से पहले भी वो डिवाइस ही बंद हो जाती है, बट वो 0 नहीं होता। दिस इज एक्चुअली रिप्रेजेंटेड बाय अ ग्रीक लेटर टॉ, which is having a strange symbol, and its unit is second. So now you have to copy this screen.
Done.
Now, what is the idea? That it is a time taken, time constant is the time in which the capacitor decreases to 0.37 of its original value. It now time का बेसिकली टाइम कांस्टेंट का फायदा क्या होता है, हमें ये पता चल जाता है कि कैपेसिटर कितनी तेजी से खाली होगा. So when you are designing any machine, any circuit on capacitor, you would know कि कैपेसिटर कितनी देर में खाली हो जाएगा. We have a formula, tau is equal to RC, where tau is time constant, R is resistance, and capacitance of capacitor is farad. Now you have to copy this.
Done.
Now R into C, देखो R का यूनिट है रेजिस्टेंस और ओम है, और अगर हम उसको if we go in our A level, AS level, so we can recall the base unit work on tau is equal to CR. Now, this is something we can work out, and we can check that how system is showing the unit here. Now, if you see C into R, C is capacitance, okay? C is capacitance, which is in farad, and R is in ohm. This is there. And we want to see how we can further translate it. What is capacitance? Q is equal to CV, and C is equal to Q upon V, which means farad is equal to coulomb per volt. And what about resistance? Resistance is equal to V upon I. So it means ohm is equal to volt upon ampere. So copy this solution.
Done.
Now, if I continue this calculation, this workout, and I was stopped at farad into ohm. So what I can put in place of farad? Coulomb per volt. So I can put coulomb per volt. And what I can put for ohm? Ohm is volt per ampere. So what I can cancel out? So I can cancel out volt. So what is now left? Upon ampere. Now you have to copy this. So when I put it back, ampere will cancel. So this will be a justification that tau has a unit of second. So this is a base, this is the power of the base unit, and you can prove that the time constant has a unit of second. So copy this small type of derivation.
Done.
Could you recall this derivation, these workout, these base units from
Yes.
AS?
Yes, sir.
Good. Now, this is an example. I will post you later on this one, that a capacitance of 7 nanofarad is discharged through a resistor of resistance R. The time constant of the discharge is this much. Calculate the value of R. So what we are doing first, we are first converting nanofarad. Look at this step, nanofarad into farad, and time constant is there. So what we do, we put the formula, rearrange it, and got the calculation. This is a simple step calculation to show how we can use this formula. Now, general equation for discharge. You have to copy, you have to give this heading. It's a side heading.
Done.
Now, look at this formula. X is equal to x naught e power minus t upon RC, where x naught is the initial value, x is the final value, e is the exponential function, t is time, r is resistance, e is a constant. जैसे मैथ्स में constant होता है ना पाई, इसी तरह e is a constant and it comes like this कि उसमें exponential values होती हैं, value constant होती है. अब ये जो फॉर्मूला है ये आपको याद करना है, और इसमें x और x नॉट का मतलब है इनिशियल एंड फाइनल वैल्यू. नाउ यू हैव टू कॉपी दिस.
Done.
Now this is the formula, and this formula is actually a general equation. General equation किसे कहते हैं? Which can be modified for a number of other variables. तो ये जो equation है, ये चूंकि नया टॉपिक है, तो एज अ न्यू टॉपिक यू हैव टू रिमेंबर कि इसके ऊपर अभी बहुत ज्यादा क्वेश्चंस नहीं है, एंड दिस टॉपिक दे इंट्रोड्यूस लास्ट टाइम, लास्ट ईयर. सो इसमें आपको यू हैव टू रिमेंबर ऑल द पैरामीटर्स वेरी केयरफुली. So when you look at this formula, this formula is showing that there is an exponential value. अब exponential value क्या होती है? It's a maths function. जो चीजें एक कर्व में जाकर स्लो डाउन होती हैं या कर्व में इंक्रीज डिक्रीज होती हैं, उनके फॉर्मूलाज में ई वाला फंक्शन आता है. ई मैथमेटिकल फंक्शन है. नाउ यू हैव टू मेक इट वेरी क्लियर, बिकॉज if a student is not taking maths, that E can give a problem. In your calculator, you can find this E on the button which is written with ln. If you have a calculator with you, you can look at this calculator if you have it, or if you have an app on your mobile, जहां ln लिखा होता है log का function, उसके ऊपर लिखा होता है E. It is a calculator function. Okay. Now this formula can be written for different variables. ये फॉर्मूला I के लिए भी लिख सकते हैं, V के लिए भी लिख सकते हैं, and Q के लिए भी लिख सकते हैं. So after copying this, write under it that this is a general equation. This is a general equation
Done.
This is a general equation. It can be modified for 3 variables. It can be modified for 3 variables. Now you have to copy this screen.
Done.
So it means ये जो फॉर्मूला है, इसको आप, ये फॉर्मूला जो है, इसको आप 3 मरतबा लिख सकते हैं. ये फॉर्मूला करंट को भी डील करेगा. दिस विल बी डीलिंग वोल्टेज, दिस विल बी डीलिंग चार्ज ऑल्सो. So one formula is dealing all the functions. Now it's a curve. Look at this shape of the curve. It's a curve, and the value of tau remains constant. The curve is coming down. It is called an exponential decay curve. The value is remaining constant. In exponential decay, the time taken to reach half the original value is always the same. You have to copy this.
Done.
Now we have discussed this idea. Tau is equal to CR is basically a formula. Tau is equal to CR is a formula which is showing the time constant. Exponential जो curves होते हैं, they do not touch x-axis. They do not touch x-axis, and this is where exponential function is there. So write under it in a bracket. Write under it that E is a calculator function. E is a calculator function. E is a calculator function, and if you have a chance to see, look at your calculator, you will find it that it is a calculator variable, and you have to look on the calculator small buttons. the calculator, small buttons, and there you will find a button with ln. ln means log, और उसके ऊपर ये बटन मिलेगा. ये सीखना जरूरी है because you can't solve the questions on this formula until you have a good grip on ln function. But I will inshallah explain it more on this in the next class. Now you have to see some important points. The faster the time constant, the quicker the exponential decay of the current when discharging. अब टाइम कांस्टेंट जितना शॉर्ट होगा, इसका मतलब होगा कि कैपेसिटर will discharge very quickly. So we design two types of capacitors, some which discharge very quickly and some which discharge slowly. So we just keep it up to here, and we will inshallah continue this in our next class. Allah Hafiz.
Allah Hafiz.